Now I need to make my slides longer than the bio. So, as I was kind of walking up, I thought it was kind of funny. I think a lot of us have many things in common today. Probably the most thing, the thing that we have most in common with is no one is really sure as to what is it that my topic actually entails. So, but no, thank you for the lovely introduction. Agenda. This makes me sound like a Bond villain. But essentially, I wanted to talk to you a little bit today about the problem of information overload. It's come up a few times. But since the topic also includes diversification of business models, what else can we do as publishers, but at the same time, make ourselves better for our end users as researchers around the globe? How do we combine all of this and make society better? We'll start off with what's pretty common. Everybody has spoken about Google Scholar, and I get to speak to a lot of researchers. I've worked in the lab for more than 15 years now, and Google is something that comes up very often. My personal opinion is Google Scholar is not particularly great, but that's just me. Simply because of the way it searches for information, you probably don't scroll past the first 2 pages if you get 1 million results, but yeah. I think it's an important tool for researchers, especially when you want to search for information from everywhere. But one fascinating trait was when talking to a lot of researchers, trying to find data today, was that a lot of people actually, or researchers told me they use Twitter for some reason. I'm not entirely sure why, but when I kind of tried to dig in deeper, they said social media is important because that's where people kind of tweet the most important papers. So, sounds interesting. Maybe we might want to start scraping social media for papers, but I think that's a dangerous road in itself. But anywho, okay, so you have Google Scholar, you have Twitter, and then of course you have information from various sources around the world. Now my topic is going to revolve around machine learning and AI, and especially the kind of things that we are doing at Springer Nature today, working with academic and government labs, but also various corporates. So I'll share a few interesting case studies as well as use cases that we're seeing today with respect to how data is being used in various corporations around the world. Now, AI is, of course, maturing. We've seen Alexa and Google Assistants and whatnot in our homes. It can do better in terms of understanding our language, various accents and dialects, etc. I know it certainly struggles to kind of identify or always understand what I'm talking about half the time, especially because I don't think it picks up my accent very well. But yeah, that's where AI stands today. But it's also important because most of this is being trained by language models, by voice language models from various groups. And that's important because that's the information that's going in. Similarly, for research, you have a lot of information, of course. I think Springer Nature, my last count, has something like 3,000 journals. I don't work on the journals and book side, but it's always fascinating to me the amount of journals we have. And which also means there's a lot of content out there. And of course, we have lots of other great publishers and a lot of content. And I think the first 4 months of the pandemic, you had something like 400,000 papers on COVID alone, which meant if you're a researcher searching for information, how do you find out papers that actually are going to be useful in identifying certain traits or certain diseases, certain symptoms that can help you make a drug that could potentially treat a specific disease, which could be COVID or something else. So here we've seen quite a lot of advance. This, especially DeepMind, came up with a few interesting things in kind of solving protein folding. And a lot of this was done by text and data mining information. And when you want to text and data mine information, of course, you want to be able to get to information which is structured, which kind of goes beyond surface level information that you're going to find in PDFs. So how do you make all of this available in machine readable formats, XMLs, but also kind of enrich that information, have semantic enrichment, connect the dots, and so on. And that's the crux of what I'm going to speak about today. Now, I've seen most of these discoveries and advancements happening in life science and pharmaceutical sectors, which is not surprising to me because That's where we see a lot of advanced use cases, especially with drug discovery and repurposing of drugs and so on. But I also see smaller life science startups being very interested in information that publishers have. So if you have information related to biomedical sciences, life sciences, anything else in the physical sciences, I think there's a lot of interest there to kind of go beyond just reading PDFs. So how do you make sure that you have information structured, especially in XML formats, but also in JSON and so on? And how do you build sustainable business models that would kind of really help organizations, especially smaller ones, and then kind of scales up? So for machine and deep learning studies, we've seen a huge increase over the last decade or so, but especially, as I mentioned, in the field of life science and pharmaceuticals, I think you cannot make a lot of discoveries without the help of AI. And this would include things like, for example, you have drug discovery, but also being able to kind of look at phenotypic and genetic heterogeneity and many other types of applications here. So what this means is, let's say, if you're able to go through scientific literature and identify certain kinds of symptoms, let's say you might kind of connect the dots between, I think there was a slide earlier today about whiskey, or was it cigarettes? I forget. But is that truly related to cancer? Yes, but are there other factors influencing it? Could it possibly increase your risk of cancer, lung cancer, or decrease maybe perhaps? So you can kind of connect all those dots through the help of text and data mining, through the help of machine learning and AI. And a lot of this AI-driven processes is where we are starting to see real growth when it comes to publishers. So what are we trying to do at Springer Nature? So one thing is, we want to kind of make sure that there are three aspects covered when we kind of dive into machine learning AI. One is we want to look at compliance, which means, of course, you want to have precise results when you kind of go into the data itself. And that's more efficient than, say, human intelligence, because you can kind of go through multiple papers, hundreds of thousands of papers at any given point of time. But also make sure that, as the saying goes in machine learning AI, garbage in, garbage out, which means that if you have bad data, then you're going to have bad output as well. How do you make sure that when, as a publisher, you have information? I think there was an important topic earlier today about diversity in publishing, but not just about employees, but also about how do you make sure that you have research coming in from all parts of the world, from every society, such that you can actually use machine learning and benefit the entire society rather than one part of the society. So for instance, we work with a lot of pharmaceutical companies who might be using this information to identify drugs based on symptoms. So this information is based on only a portion of the data set. So when you're publishing information from various, or kind of collect or aggregate information from multiple ethnicities, kind of increase the demographics of the data sets, that also allows the machine learning capabilities to be able to kind of really go in deeper and find the best possible results. So what this means is you can actually identify skin cancer better, because now you have various types of skin that you're actually taking into account when you're kind of mining images, for instance. So this is extremely important when it comes to ML and AI. So for us, there are 4 levels that we kind of look at Springer Nature. So one is kind of structuring the information. How do we make sure that all of our information is structured in a particular manner? For example, we kind of structure it around text, images, and also other kind of applications that allow organizations to pick and choose what they want. So if they're interested in data just around images, they can do that. If they're interested in information around data sets, they can do that. Do they want ontologies or taxonomies? They can do that. So if you're a publisher, maybe that's something, I think if you know me, I've been ranting about this for like 3 years now. So I think it's important for publishers to kind of diversify and start looking into your own data sets. You have a lot of information out there. So can you kind of structure it in a manner and then look at these opportunities? And I can certainly tell you that there's a huge market out there for such opportunities that we are already seeing massive interest in revenues coming in too. Number 2 is forecasting, which is, of course, kind of predicting trends. I'll dig in a little deeper in just a minute, but you can use this for kind of identifying growth areas yourself, or you can kind of help others identify certain spaces where they could invest in such that they can make strategic decisions. So for instance, we work with the White House to identify certain areas where you can maximize the impact of funding. So that's just one use case. So how do you do that? You can do that with the ability to kind of really connect the dots between the impact of research, which was a fascinating conversation I was having with Steve, and I'm sure he's going to talk more about it in his conversation with you, but that's an area, for instance. Linking. So this is basically kind of things like where we've had financial companies kind of looking at the information that we have within our publications, where let's say you have energy-based publications or you have information about material science. I've had Samsung, I've had several chemical manufacturing companies kind of dig deeper and see if they're able to find out which researcher or which part of the world is finding out certain types of materials. And then that information is then being sold to fintech companies who are able to kind of see if the market is actually moving based on that information. So market indices is also moving based on certain publication-based information. So that's what we call as alternative data sources, powering products. So perhaps some of you are already aware of this and have more knowledge than I do, but this is an area that I see increased amount of interest in both finance, smaller companies and larger, like for example, Bloomberg, as well as younger fintech companies. This is a slide that we actually adapted from Outsell, which I think was a really good slide. So from our perspective, we have 5 different value chains. Number 1 is at Springer Nature, we have started kind of really digging deeper into our data, making sure all of the data, as I mentioned, is structured. Then we have started enriching that information. When I say enrichment, this means extraction of certain types of data sets. If in life sciences, we see 60 to 70% of our customers in life sciences pharma. So that means kind of looking at antibodies, antigens, things like equipments and so on. Can you kind of take all of that information, package it, and then maybe sell it? Workflow solutions. I take the example of life science pharma. You have electronic lab notebooks who might be interested in integrating some of your content directly into their software. Could you do that through your APIs? If you don't have APIs, could you build them? If an investment in APIs is difficult, look at your cloud solutions today. If that's difficult, maybe you can kind of deliver it straight into their servers. There are many things that you can actually do that allows organizations to ingest your data into their proprietary systems for advanced use cases. So that's where we see workflow solutions. The other 2 are highly advanced, and I don't see a lot of applications there today, but I certainly see that in the next 5 to 10 years, especially in predictive analytics and prescriptive analytics, which is basically kind of changing the variables of certain experimental information and seeing what the output might be. All right, so basically that's the kind of information play that I'm seeing, or state of play as far as information data today. And for us, text and data mining is turning into an important source of revenue, at least at Springer Nature. And I think this is especially important as we've kind of moved from information retrieval, such as like print indexes, catalogs, to like bibliographic databases that have Boolean search, to full text databases, and now, of course, semantic enrichment and text and data mining. So here, if you're able to kind of go into taxonomies, ontologies, TDM, I think this is where it's a good place to kind of begin when it comes to diversification. And in today's context, I would say TDM, I see usually 2 different use cases. One is discoverability of information. So for example, let's say you want to look at all information from many different publishers, and you can kind of really connect the dots between, like I said, glutamate and OCD. And you only find out papers where glutamate is actually having an effect on OCD. Or, for instance, pattern discernment. So in this particular case, you're not really looking at information which is based on, say, precision or accuracy. You're not even looking at articles. You're mainly interested in finding out patterns. Are more people interested in graphene in a certain section of the world versus, say, perovskite or whatever, some other chemical in another part of the world? So how is that moving markets and so on? So that's pattern discernment for you in text and data mining use cases. And this is especially important, as I mentioned, when it comes to drug discovery. One key example that we saw and we worked with quite a bit is Benevolent AI. If you're familiar, they're a startup that actually kind of utilized this information going into their systems. So we were able to provide them with structured and enriched information. And they were able to kind of create 1 billion relationships between all of these different things like genes and symptoms and diseases, proteins, and so on. And then they were able to answer questions like which gene is associated with a certain medical condition, or which compounds have been shown to affect it. Similarly, we have also seen a lot of interest from defense. I think there was another good case study earlier today. So we have seen organizations like DARPA and a few others also quite interested in text and data mining and then kind of connecting the dots and answering questions such as this. And like I mentioned, we see a lot of interest from pharma and life sciences. These are just some of the companies that we work with. Academic and government labs is a huge portion where we see the most growth in. In the last 5 years alone, I've seen about 9,000 universities really get into text and data mining from around the world. And you see increasing number of use cases where they're able to take this and then start companies. So if you have text and data mining, which I'm sure most publishers do offer in some manner of speaking, kind of XML formats and APIs or data feeds, I think this is a good place to kind of really look at deeper and see what else you can do with it. But how do you kind of talk about business models? I think I kind of left that slide out. I don't want to talk about more use cases, but I think business models is an important part or an important consideration of text and data mining today. Traditionally, publishers have always had, doesn't matter who you are, most publishers have a very similar business model. But let's say if you are interested in text and data mining, how do you kind of really make revenue? So the key part is to actually move away from a content-based model into an actually usage-based model. So what that means is, let's say if you are a startup that's interested in mining information from within your content set, your data set. Now, obviously, a startup company does not have the required amount of funding to be able to pay you, I don't know, hundreds of thousands of dollars or euros or pounds or whatever it is. So how do you build a model that actually scales? So here what you can do is to actually look at their current valuation. Who are their investors? Are they in seed funding? Are they in Series A, Series B, Series C, and so on? And instead of having a fixed licensing fee, you start off with a fee that actually reflects the value of the company at the moment if it's in seed funding. And then you build a contract around kind of scaling that as they get more funding. So that's very important because now you don't want to give the value of your content away for something like $5,000 when later on that company that's able to use that information then goes on to be valued at tens of billions of dollars, which is something that we've actually seen. So it's important to be able to build models, business models that actually scales with the growth of the company rather than actually stick with one particular model. Now, at the same time, it's important to be able to kind of consider if they are a large organization, then you have more similar kind of business models, or perhaps you kind of move into a monetization model that's based on API calls, if you have APIs. So I think, or if you have cloud services to kind of see if you can actually upload all of this information, build a federated sandbox where they could come into your systems, maybe have machine learning algorithms work there, GCP, AWS, all of these actually offer that, and then they take the output away. The output actually determines the pricing itself. So you could kind of build a model based on that for larger organizations. Of course, for academic and government labs, it's a whole different story. In this case, you want to be able to offer text and data mining that actually helps them rather than kind of looking at revenues there. But corporations, I think, is an important aspect of how you can kind of see where you can both contribute, but also make a sustainable business model where you're able to have recurring revenue. I feel like I've been rambling along, but this is also the first time I've been doing this for nearly 3 years now, face-to-face, so I apologize if it sounds like it's all not kind of disjointed. But essentially what I'm trying to say is, as a publisher, it's important to be able to look into your data sets, kind of see how you can aggregate all of that, make sure you can structure it, enrich it, and then identify markets where you think it makes the most sense, where corporations might be interested in your data sets, and then have sustainable business models that allow you to maximize the value of your content. And that's how you will diversify your content set and diversify your business models. Within Springer Nature, we have a bunch of different services. So we built a lot of APIs. At last count, I think it was something like 40 different APIs. We've built several cloud solutions and data workbenches that allow most companies to be able to kind of extract information from our content sets. But if you're interested, all of this information is actually available for you at api.springernature.com. And we also built the largest open access linked knowledge graph in the world in SciGraph. So for those of you who are familiar, you already know about it, but if you're not, then SciGraph contains a lot of information from authors, articles, books, clinical trials, patents, and so on. And like anybody is allowed to use that information. So I believe at last count it's something like 1.75 or 2 billion triples, which might not be much in comparison to Google, but I believe it's the largest of its kind from a publisher in the world. So that's open for all. So I think SciGraph is being used, again, by my last count, there was something like 1 billion hits for our APIs last year alone. And that's basically it. So thank you so much for listening to my kind of rambling along talk today. But if you have any questions around how text and data mining is being used today, what are the use cases, are we seeing interesting business models, and how they're kind of, what kind of uptake there is, I'm happy to answer all of those questions. Yeah. I'm actually really glad I followed your talk, so.
Thank you, that was really great. I have 3 questions.
Sure.
So the first question, you've got a lot of content, but you don't have all the content.
Correct.
What's the sentiment from your customers about that in terms of the value you're driving for them? Do you find you have enough to drive value? Do you find there are customers you can't capture because they want to feel like they've got a complete record? How do you manage that?
Yeah, that's a fair question. I'd actually answer it in 2 different, kind of break it down. I think customers prefer to have all the content, not just from, say, Springer Nature or a particular publisher. They will always prefer as much content as possible. But at the same time, if you're a corporate organization, you could probably only have content set from 1 or 2 or maybe 3 publishers because of the way commercial business models work. In that case, we sit on some of the largest life science, biomedical content in the world, and 60 to 70% of our customers are from life science pharma. So I think for them, the data sets is a good start, and then they look to expand. Yeah.
Okay, question number 2. When thinking about building an API-driven model, where you have customers where their use cases are now emergent, where do you place your bets? Do you place your bets on having a really opinionated API that they have to change their systems for, or do you place your bet on building a system that can help you mold the data in the shape that your customer wants? Do you have have you had to like struggle with that tension?
Yes. So the short answer is yes. We've actually started going from number 1 to number 2. I think it just scales better. But at the same time, I'm starting to look at cloud as rather than a complementary solution to APIs. And when I say cloud, I think, as I mentioned earlier, not just uploading all the data into the cloud and calling it a day, actually building something where somebody can come in, run machine learning algorithms, take the output, and go away. I think that would be the future rather than APIs, in my opinion. I think that makes the most sense for me. Yeah.
Okay, and my last question, and I have so many more, but this is what I'm really interested in. When you're enhancing your content, what kind of pattern have you found most useful? Do you try and embed those enhancements in the original documents, or do you try and sidecar them into some other data system?
Not so much in the original document, but we actually prefer kind of having its own data silos, which we can then package and then offer to organizations which might be interested in that. Because I think it kind of, I'm not a technical expert there, but we found it to be tedious to kind of go into documents because of various reasons. Also, I have to say at this point, I know Pooja was from Springer Nature. I don't know how many Springer Nature folks are here, but it's also not easy to convince leadership to actually change and do certain things. So that's probably been my biggest roadblock rather than anything else. Yeah.
Thank you very much.
Thanks.
Thank you for your talk. It was really interesting. So you made it sound really easy.
It's not. Sorry.
You just got all this data, and then you structure it really well, and then you package it up and you sell it. What advice would you have for a small publisher with not particularly deep pockets about how they get the best value out of their data, which is quite unstructured at the moment?
Yeah, it's tough. I would start by looking at where your data sets is likely to make the most impact. I would validate that market, go out and see if there's actually demand for that information. And if you have the resources, then I would start by kind of a smaller data being kind of packaged, structured, and then see if you can kind of go back to that organization who might be interested in a data set, again, validate the use case, and then go from there. So I would actually take that approach. If you don't have the resources to kind of dig deeper, kind of go in through all those 5 levels that I spoke about, then that's a good place, provided you have validated the market, and that's key. You could look at vendors, you could look at even partnering with other organizations. I know there are a few out there who actually kind of aggregate information and kind of do that work for you. But yeah, I think that would be the way to go. And that's essentially that's the journey that we went through, for the last 5 years or so. Yeah. So thank you so much. I hope I have not bored you to death, but thank you again.